Alright, so today we're going to start a new web series on how to build a game. What this video series will entail would be me building the game. It isn't, I guess, an instructional video exactly, but more of my thought process and my process of going through how to build it. If you watch the whole thing, you'll probably learn how to build your own game as well and also learn some neat design tricks. If you're just trying to build an example game as soon as possible, this is probably not the right video series because there's probably shorter guides. But nonetheless, I hope you subscribe anyway so you can keep up to date on the whole series. A lot of this isn't prepared in advance, so therefore it's more stream of consciousness. You'll see me do it as I do it. And yeah, I might make some mistakes too, but that's how I'll go over what to do and what not to do. So let's talk about what we're going to build. We're building a social deduction game called Mafia. And in this game, for Mafia, users are given a role. They can be a normal villager, they can be a killer, or they can be the police. And our goal is to find out who the other players are. At each turn, the killers will kill one person each. Police can check rolls, and villagers do nothing. Each turn at night, and then each turn at daytime, everyone together can discuss what they think the killer's identities are, and also vote out one person. So we're going to build this game for mobile. So this will be on the Android and iOS app stores. Reasoning for that is because if it's web, the current advertising programs like AdSense do not really fit for that because it's based on context. So if it's based on context, then if it's a game that's dynamic, you're not really getting a lot of word context or search context based off of that. But mostly due to ads and retention. Also, if you have the game installed, you're more likely to play it because it's already on your phone and it's an icon, versus if it's a website on your phone, you have to kind of remember the website or bookmark it. And well, when was the last time you ever checked into your bookmarks to see what you've bookmarked? It just grows and grows. So how are we going to do that? So let's talk about tech stacks. We're going to use React Native for the front end. The reason for that is because I know JavaScript already. I don't know Swift or Kotlin or Objective-C, so therefore it's just an easy way to build for both Android and iOS. For the backend, we're going to use Node.js Express. Reason for that is also because I know JavaScript, so hence that's the design choice there. For databases, we're actually going to do something a little bit different. We're going to be using MongoDB, which is a NoSQL database. And we're also going to use Firebase real-time database. So normally you only use one database per, I guess, application, and you choose your database based on what you need. So for example, if it's more document storage, then you go for something NoSQL related. If you're doing something that requires more relationships and joins between data, and you don't want to duplicate that data, then you're looking for more relational database. But in this case, we're using two non-relational databases, Mongo and Firebase. And the reasoning for that will be somewhat clear once we elaborate on the requirements. But keep in mind that this is a bit of a quirk, and let's find out why. So how do we have this game? The front-end React Native is just the user interface. So that just lets users play around and send commands. Essentially, it's similar to a web application. The problem with web application is it's very good at asking for data and getting data back, but it's not very good for synchronized data. So what I mean by this is, think about how a website works. You send a request. So that's maybe you're going to a website by typing the URL into your browser, or you're clicking a link. The server gets the request, processes it, and returns a result. And the result is what you see back in your browser. So that's kind of how it works. It sends something, you wait a bit, you get something back. Now the problem is when you take an action, it fits the model above, because when you take an action, say you're clicking attack another character, or you're clicking create account, that follows that model really well. You're sending a request with information, the server gets it, it processes it, and gives you a result back. However, when other people take an action, it doesn't work so well, because you're not sending a request. You're just sitting there waiting, and you want to be notified when someone else takes an action. So there's several ways that websites usually deal with this. You have periodic checking, or polling, or whatever you want to call it, where every so often, like every 10 seconds, every minute, whatever, you send a new request and you get a new response back. You can do something called long polling, and what that is you send a request and the server doesn't reply. It just kind of waits until there's an update, then they send you a request, and you automatically send a new request right afterwards. So that way your connection is always open. There's WebSockets, which is a constant connection with the server that's constantly open. And this is the kind of preferred way, because it's a lot more efficient in a way than long polling or periodic checking for a lot of cases. Of course, not all cases, but for example, the problem with long polling is you always have that connection open and hanging, and web server requests normally aren't, I guess, designed that way. So some servers like Apache, for example, when they have they're not very memory efficient when it comes to that. Some event-driven architectures are better at that, I think, but I'm not too sure on this because it's a bit out of my depth. But typically WebSockets is a little bit more preferred compared to periodic checking as well, because periodic checking, sometimes if it's, say you're checking every second, but the other users take an action between every second and every like 5 minutes. In that case, you're checking a couple hundred times when you don't need to be checking. So it's a lot of wasted requests, a lot of wasted resources. So those are typically the ways to deal with it. We thought about using WebSockets, but there's a problem with WebSockets, is that if we're hosting our app on something like if we're having, for example, one server, it's pretty easy because you keep all the connections in memory. So when you need to update, you just send message to all connected clients filtered eligible connect clients. So in this case, say for example you have a server with 10 rooms with 10 let's say 20 players each. So when you get an update on, say, room 5, you just do a loop and send the message to all clients in room 5. So that's pretty simple. But now what happens when you scale? So by scaling, it means when you get a lot of traffic and you need multiple servers. So say you have player 1 in room 5. Does an action. So in this case, how do you get all the players in room 5 notified? Because maybe players 1 to 5 are on server 1, players 6 to 20 are on server 2. So in that case, you need to talk to the other servers as well, and they need to send it to all their clients. Or other potential problems is, what if you have a drop connection? You need to reestablish it and make sure that it's the same player. That part isn't too bad because, for example, you can have a unique client ID that you give into the client, and then by client I mean like the player's device, and then that way you can be notified whenever he connects that, oh, it's the same client, just add them back to this pool. So there's a couple of problems, I guess, with that. So the reason why we're using Firebase real-time database is because it takes care of all of that for us. Because when data changes, all clients automatically update. It also handles clients that go offline and back online. It also handles when the client's not available to receive that data. So it handles of problematic scenarios for us. So that's a good thing. There are downsides of using Firebase real-time DB in that you're kind of locked in. So if Firebase decides to go to business, then, well, no more database, no more game. But typically, well, Firebase is owned by Google, so I don't think that's going to be too big of an issue. There are other, I guess, considerations. Firebase real-time database also has a security policy because unlike typical databases, so typically for web apps, clients will connect to a web server, which then connects to a database. So for example, when you go to a website to register an account, you click register, it sends it to the database, to the web server. The web server handles that request, checks your information, make sure it's right. Then, assuming everything's good, it'll store the account details into your database. Same thing when you log in, but you can't really see the database directly. There's no direct connection there. However, with Firebase real-time database, the clients can go through web server to database, and the clients can go directly to the database. So security rules are very important. So the security rules in Firebase is kind of like a hierarchy where it determines what users can access and what data that is accessible by them. So part of the reason why we're using Mongo is because I don't know Firebase security rules that well. So because of that, making sure that the data is hidden for some users but available for other users, it can get a bit complicated, at least for me. And also I want another persistent store anyways for things like analytics tracking or cloud messaging. So I'll use Mongo as my main, I guess, server store, and then I'll use the Firebase real-time database just for that public, for a publicly accessible updater for clients. What that means is I'm going to, so let's go back to the game where the players can take actions. When they take an action, they're going to tell my web server, hey, we're taking this action. The web server is going to process it, and the server is going to update the database. The benefit of real-time data, Firebase RTDB is that when it updates the database, for example, player 3 gets killed, all the clients that are connected and listening to it automatically get that update. So they see that player 3 got killed. And same thing when the stage changes or when it's someone else's turn. All that stuff gets updated to Firebase real-time database, and all the clients know about that. However, there are things I want to keep hidden. For example, who the killers are, who's allowed to take the actions. For example, you don't want a villager killing someone. So all that hidden stuff is going to be stored on Mongo, and all that public stuff is going to be stored on Firebase RTDB. There's a way to do it all on Firebase RTDB, but I'm a noob at security rules, so I'm just going to separate it. And the second reason for that is in the future, if I decide to move off of Firebase real-time database, if I want to move to something like PubSub, for example, or Firebase Cloud Messenger. Actually, it's called FCM, Firebase Cloud Messenger Messaging. But if I want to move to a different solution for notifying clients, part of my database is already persisted somewhere else, so therefore I don't have to convert it all into a different data store. So there are some benefits, but the majority of the reason why I'm doing two databases is just because I'm not very familiar with Firebase RTDB's security rules. So that's kind of like the tech considerations behind this project. Next up, we're going to... How's this video going so far? We're at 15 minutes in. So we're going to talk about the next video and what that's going to include. Because if I do like a 3-hour video, some of you might get bored, so I'm just going to chunk it up. And that also gives me time to reflect on my thoughts as well. But in the next video, and this might change because this is live, so I might decide, hey, let's just keep on going after I decide what's in the next section. But the next section, we're going to talk about the architecture for the app. And what this means is what clients are going to tell the server, how clients work, what's stored in database, and then we're going to talk about how to implement. And the implementation has several parts. There's going to be setting up, well, the design doc, which we're doing part of kind of now. And then we're going to talk about the front end. And then we're going to talk about the back end server, processing, updating databases. And both the front end app and the back end server will access the Firebase real-time database. The clients will read only. The server will write to it. But then for the Mongo database, it's just going to be on the backend server. So that's kind of what's coming up in the next video, which will be the architecture and how to implement all of this. So click that subscribe, and the next video will be coming soon. Either tomorrow, this weekend, but yeah, look for it dropping in the next couple days.